Good afternoon, everyone. Welcome back. Alright, I think it's live. How are you all doing today? I hope everything is fine and you're full of energy after the weekend to do even more encoders. Yes, right. Exactly. We still have a few more things to check. As I said, and I wasn't wrong, to my surprise, over the weekend I got this little fella, which is basically brother to this one. So this is EC11 surface mount, SMT, SMD, however you call it. And this one is the same, just that we have proper legs. So I promise we will take a look at it today. And luckily it seems like there won't be much to look at because it has the same size, the same dimensions, so it fits almost perfectly. What we can do, let's see, because of course it has those mounting legs and it has these. So let's see if I can bend this one. Would it be okay? Yeah. We can as well chop them off. Yeah. They fit okay. So also these legs, I need to check if I can bend them as well, because what is happening here, it's the same situation like with the SMD one. We need something to hold it from the bottom, so we have this tiny bump. So once everything is assembled together like this, this is like a cutout of the side. So let's see. Yeah, okay, now the legs are blocking, so I'm gonna bend them in a while. Oh, we need something to hold it in place. So let's try to bend these. Yeah, this is quite okay as well, because we have more surface to attach the wires. For this one, it's not that great, but still should be possible to solder in. But I think this one is even better. You don't have to worry about anything. Yeah. And the worst case scenario, if they are too long, we can just trim them somewhere around this and should be okay. Right, so going back to the yeah, so as you can see, now we have this is the bottom plate, right? So this will be holding everything together. And yeah, now we need that, because otherwise we won't be able to use it, because there is no thread here to hold it. So we have to rely on something that will be holding it from the bottom. And this one is okay. Yeah, looks good. So lucky for us, not much we need to do. So we have one design that fits both versions, which is very nice. Yeah, this one's quite okay. I don't know at this point if there was one with the different shaft, because this is the, I think it's D-shaped shaft. Not a problem, because we can print anything that we want. So yeah, should be good either way. Maybe there is one with the same shaft as this one. Not quite sure. I need to check. Yeah, but it's quite nice. Yeah, I do have a piece of the knob, but I only print half of it, and it doesn't really hold that well, which is not a problem, because we know it's gonna fit either way. I was just curious how it's gonna look like. See. Yeah, it's a bit too low. Yeah, maybe it needs a little bit of tweaking. Oh no, I think there is some Now there is enough space. I think we left like 0.4, so 2 layers. So yeah, should be okay. If not, can always bring it up a little. Yeah, so it's a good option for us. Definitely simple one. For the volume, we don't really need much more. They are kind of little bit hard maybe to rotate. Yeah, not that great. Okay, so we can say that this one is kind of done. It fits, it holds, we have plenty of space. And also I've been thinking, like, because right now both halves will have the same shape, the same size for the extension. So if we have a volume, we can technically swap without any issues. If you want to have a magnetic encoder, it should fit either way. The only difference would be the bottom part, because for the magnetic one we have a switch at the bottom. Yeah, so that will be the bottom part. So this one we can move switch to the bottom plate, or maybe no, not really. Well, yeah, I think we can do that. Then it will be easier for us if you would like to change, because right now it's attached to the middle part, so we can make it like movable maybe in a way. We want to think about it a little, how to make it happen. Yeah, then we don't have to worry that much. Or maybe we can attach it somehow. Yeah, something to think about later. Okay, so as promised last time, I would like to go back to this. This is AS5600. We got this one, which is EC11 This one is kind of nice. This is magnetic encoder. It's nice because it works without any additional programming in QMK. Luckily for us, it has these A and B outputs right here, A and B. And so it happens that these outputs, they have the same signal output like a typical encoder, like this one. So we can just hook it up to QMK. Let's say we have a standard encoder in QMK setup. We have 2 pins on the controller, like for example over here I have pin 2 and 3, and we can just read it as a normal encoder. The only trick is that we need to have a high resolution, so resolution of at least 64, because it's super sensitive, and anything like that is like smaller, so just a tiny bump will make change, for example to volume or whatever we have. Okay, but today we're going back to AS5600, and I would like to give it a shot. I would like to try to read it from QMK. If it's possible, that would be great. Yet another option for us to have. And the good thing is that, you know, magnetic encoders, we can drop a bearing on it, and it's super smooth, super light. It's really great, and it's very sensitive, very accurate. So definitely beats something like this. Yeah, okay. So what we need to do, since we have a setup for MT, so I have to desolder. I think I should have, yeah, okay, it's here. So I do have it already wired up. All right. We need to do quick swap. I think I can get rid of these resistors. They didn't really help much. A volume and I2C. All right. was supposed to buy more resistors because I'm kind of running low. I should at least get those that are most frequently used, like 10k, I don't know, 1k maybe. .68 ohm for infrared. Okay. Okay, so this is VCC. Okay, now ground. And what do we have next? Data and clock. So data is blue one, and it's pin number 2. And the clock is number 3. Quick check. Okay, data is the blue one, goes to number 2, clock goes to number 3. And then we have VCC goes here and ground goes here to the ground. Okay. Okay, so we have this mockup. I think I can use it. Okay, so that is one thing. Alright, so I think in terms of wiring, we are done. Okay, let's take a quick look over here on the spec sheet. What we are looking for are the registers. Okay, this. So we have row angle and the angle. Alright, well, technically that is not that much of a problem because I already have it done in Arduino. Yeah, exactly, over here. Okay, maybe we can start with magnet detection over here. That's what I managed to add. Okay, that's the register. Okay, and this is the angle register. Okay, that's this one. OE, yeah, right. Okay, so Visual Studio code. Let me clean it up a little. Okay, so this is our old config. Okay, it's set up for... I think the setup is for where the I2C is, so I think we have to get rid of it. Okay, so we don't need this. And over here, we can comment this out. So I'm gonna leave this one. I think that was pin number 4. Let's take a look. Yes, D4. Yes, number 4. So, okay, number 2 and 3, we have free for I to C. Okay, so let's take a look, for example, at Chordie. We're gonna need this part. Okay, yeah, so because we'll be using I to C, I guess we need this. We don't need that, and we don't need that. Okay, let's take a look at over here. To see driver, what do we need to do? Okay, so we still need this I2C driver required. It's gonna be like this. Okay. All right, so I think that's it for... We are on default, so D0, D1, so that is fine. Okay, so I think that's it for the rules MK. Let's take a look over here in Chordie. Do we have anything interesting? Okay, so we're gonna be needing the address of AS5600, which over here it says it's 36. But there is something about, okay, 7-bit value. I think we have to shift it, right? Because let's take a look. Where is my calculator? Gone. Ah, over here, hiding. Okay, what I wanted to check, because the address I already have, for example, over here, 27. And QMK says we need to shift which way? Left. What is the address for this thing? Okay, so the address is 100, let's say 100, and then we have, let's say, 111. Okay, so this one is not really shifted for this. Okay. At least I'm not shifting for over here. Okay, so let's take a look. So let's do define. Hmm. $36. Okay, so that's one thing. Let's do define AS5600. So this is the register that holds the value if magnet was registered or not. With 0B. Okay. I mean, there's a little bit more stuff over there. So we have to mask it, right? So it's gonna be... That should do the trick. Because if you look at it over here, I managed to read it from Arduino already. But this register holds a little bit more stuff. Yeah, this one. So it's a 8-bit, right? Status. So what is interesting is this one. Bit number 5. I think that's magnet detected. Yeah, this one, MD, magnet detected over here. So we need a mask. So we have to 1, 2, 3, 4, 5 zeros, 1 and then zeros, right? So this is what we have over here. 5 zeros, 1, and then we can, whatever we read from this, we can mask it and we'll be able to tell if magnet was detected or not. Okay, so that's the basic stuff. Okay, so now we have to initialize I to C. Let's take a look how we done it in Chordie. Let's config.h. How about this one? Okay, so we have used this function over here. Oh, hey bro, how are you? Came to help? Cool. Make it work. Not sure if it's gonna help. I think I need new file. Okay, but this is for MCP, and over here oh yeah, okay, so we need to initialize, right? Okay, so this one is okay, I think we need to take a look at the source code. Okay. I2C init. Okay, it's void, so we don't need to do anything. Okay, so now it would be nice. Let's say this one will initialize the I2C for us. So now we have to try and read the value from this register, and for that we could use some kind of a function that is called repeatedly. Let's see if we have anything like that. To check some other stuff, something, I think there were some kind of functions that were, for example, when the matrix was done scanning, I think there was one call over here, useful functions. Okay, process record user. Okay, so I think we can use this one, maybe process record user. Okay, so this will be called every time, say, Only when a key press is done. Maybe there is something else. Okay, I forgot one more thing. Okay, if we take a look, we have to enable console. Let's do this matrix. Yeah, so we need to enable debug for sure. Yeah, I would just copy the whole thing because these are different functions, right? This one is pre-init and this one is post-init. Okay, we don't need this. We also don't need to debug the matrix, I suppose. All we need is just to have debug enabled. And over here, console needs to be true. Okay, maybe I will leave this one. Then we will know if we even have output, debug output. So we do have one key, right, on D4. Is it attached? No, it's not attached. Well, maybe I'll be able to short it somehow to VCC, for example. Okay. So okay, we have I2C initialized, we have debug output. So now over here, okay, we have to, let's call it, let's call it magnet, right? Okay, so we have to read it now. How is it done? We have to write first something. Yeah, like over here, we first need to, we have to start transmission. This one is a little bit different for Arduino because I think QMK will handle it for us. So it will like start the transmission and yeah, okay, we can either use it like this, so we can write and then read, or maybe we can use I2C transmit, because from what I am reading now, we can use transmit, so it will... Okay, so maybe you can also send and read at the same time. Okay, we'll see how it goes. Because for Chordie I was using those like pre-made functions. It might take longer than I was anticipating. Alright, so let's do it like this. Status, register. Let's make it 0. Okay, so we have to use this one. So let's do it like this. So we have I2C status, the result. Let's make it 0. So let's do result equals I2C write write register. So over here we had the that's the address. So that's the address. Then we have register. Call it status register. Makes more sense. Okay. Right, then we need to send data. Okay, so if you want to read it, so first we have to write to this register. No, we have to write to, okay, 1 sec. We have to write the address of the register that you want to read from. So then when we read, we should get the value of this, right? Okay, so it makes me wonder, how is it done over here? Okay, I'm a bit confused right now, because like on Arduino we don't really provide, okay, when we write we just write the data, but to which address? Okay, let's take a look on schematic again. Okay, so we have to use two addresses, right? So first address is the address of AS5600, which is this one, so that is correct. Okay, then we send this one. This is a word address sent in the first byte in a write transaction. Okay, so we just need to send. So do we have to choose a register? Not really. Okay, I think I need to check. Yeah, let's take a look at I2C. Let's do new window. I would like to take a look at the I2C driver. The I2C master over here. So we have all the statuses. Okay, I2C init. Okay, so looks like this one doesn't really do anything for us. It's empty. So yeah, that's why they said it's weakly defined. So we might need to do something ourselves. We can take a look later on at what they did with, for example, I2C expanders, if they changed that. I mean, they definitely changed that because over here in Chordie, we have MCP init. So there is some kind of initialization for this one. So we might need to write our own. Shouldn't be that scary, I suppose. Okay, so we don't need to write, we would need to use the transmit method. So we have address, data, okay, the length, and okay, the timeout. So that's default setting. And after that, we can read. Transmit. Okay, this is, and then okay, and then we have receive. Well, maybe we can use this one because we have okay, address. Okay, it's this one. All right, so okay, so yeah, so maybe we can get away with transmit and then maybe just receive, and that should do the trick. Okay, so first let's take a look what they did with the expanders, like if they how they override this I2C init. If I can only find it. Okay. Wasn't that bad. Let's take a look maybe over here. ECA. We have some enums. Okay. Okay, so this is how it looks like. Alright, so not that much, because they're just calling this I2C init the basic one, which is not that much as well over here. I2C init, this one is void, so over here maybe it's here as well. Oh no, okay, so that's the basic one. Yeah, so looks like it will only yeah, it's not much slave address. Okay, so they are shifting this stuff. Okay, so we will need to shift it. Okay, so while I'm here, so they were kind of like doing this behind the scenes. Okay, config H. By 1. Okay. Well, if you were to write it like properly, then we should follow this. So we should have like a proper file and all this stuff. But now I would just like to take a look if it's like possible to read anything. Yeah, okay. If my understanding of C is correct, so okay, they just include this I2C master. So over here, they don't really do much with this. Makes me wonder, for example, if we take a look at the datasheet, I2C interface, because there is like a start condition over here, like every device has some kind of start. So for example, we need to pull clock like low for some time or something like that. What do they say over here? Okay, well, pull up. Okay, do we have pull-ups? We don't have pull-ups, do we? Ah, yeah, right. I think I forgot about this. Okay, that's for I2C, but do we need pull-up for this? Did they mention anything? Okay, this one, digital input, okay, internal. Maybe just a quick look at the block diagram. Okay, SCL. Do they mention anything if it's pulled up or not? Okay, I2C. Okay, I think I missed that. Operation over here, I2C. That's the timing. If we needed to do something like completely like beat banging, maybe, then we should follow this. But I don't think it's important right now. But they don't really mention anything. I can't see if we need to do pull up or not. Okay, so there is something. They do mention over here I2C consider external pull up. They don't say how much. They don't mention. Could be 10K, could be 4.7K maybe. For example, this one, this requires, I think, 10K. PCC, that's not Too much stuff. Oh, there should be here somewhere. Pretty much sure I saw it. Over here. Okay, pull-up resistor. They do mention pull-up resistor, but they don't mention the value for it. Oh, come on. Rating values. I think if we go with 10K, shouldn't do any harm. This for measuring. Okay, over here is 1K for SDA. Oh, come on. I'm sure there was a schematic somewhere. Oh yeah, over here, finally. Oh, it took so long. Yeah, it's 10K over here. Yeah, okay, so we need to go back. Lucky for us, I have two 10K resistors over here. But on the other hand, well, technically Arduino didn't need that, so yeah, I just realized that I managed to do it. Okay, my bad. Completely forgot. They do have pull-ups over here already. Okay, 10K. Oh wow. Okay, so at least one thing is done. Okay, maybe. Okay, I think I will do it like this. Let's make a proper file, because this is gonna get messy quite fast. Or maybe not. Okay, so going back, okay, this init doesn't really do much, but since we want to... Okay, I think we can rewrite it over here. Let's do like AS5600, right? Let's call it init. Let's follow what they did here. Slave address, which is not really necessary, but there is one thing we can do. I think we can implement that, because like over here, they said to do could check device connected, right? And if we take a look over here on I2C, there is a ping, this one. So we can ping the I2C bus for a specific address. Okay, what does it say? At the given address, okay. Okay, register 0 request. Okay, so okay, let's take a look. How does the ping look like over here? Okay, so it's not defined. And over here, did they do it? Read all pins, read pins. That outputs at conf. Okay, so I don't think it's here because let's take a look at this one. Oh, okay, for example, over here, this is MCP 23018. Okay, so it's doing something. I2C init, and then it waits 1 second. Oh, that's interesting. Okay, it's not defined over here. And over here, like, what's the point of waiting if this one is not doing much? I2C master. Okay, kind of cryptic to me. Okay, let's not waste. Okay, so this would be static DS. Okay, and yeah, so this is kind of like to assure that it will be just initialized once. Well, since it doesn't really do much, yeah, we're gonna set this one up and that's it. Okay, that is interesting. Looking at this thing. Okay. I think this is like when we want to read or write. So this, okay, this should be okay because like if we send data, so clock will be like this and the data will go up. Okay. So we have this part. Okay, so this init is okay, let's say. I think I'm gonna borrow this. Okay, so since we have this slave to address, so let's do it like this. It will be easier. Okay, so now we need to use the standard function, right? Like write register and so forth. Let's do it like this. 5600. Let's do it right. Do we need to pass the slave address? It's constant, right? So yeah, we don't have to worry, because like over here for the expander, so the address can change, and over here we have it fixed, so we can skip that. So we know the address already. So right, so then we need to do, so we need a register to which we're gonna write. Do it. Okay, so yeah, that should do it, right? We just need the address. So now we have status result, right? And I2C. Let's take a look. Okay, so transmit won't do because it will just send some stuff to this. We need to send to particular register. So I think we need to use this one, right? Write register. So we have device address, then you have register. Oh no, maybe not. We don't have to write. Okay, we can just write to. Okay, so transmit should do. All right. Yeah, so this should be okay. We just need to send it. Like we don't need to, because the address is sent via transmit. So then AS will pick it up. Will pick up this data. It will read that we want this kind of a register, and then to respond with the value of this register. So we need to do, I hope we need to do transmit. Okay, I think I will just move everything from here, so I don't have to jump. Like this will be easier. Okay, so we need to transmit. So the address, so it's gonna be AS5600 address. Then the data that we want to send. I wonder if it's gonna work like this. Most probably not. Okay, length is 8. And timeout will be default. Okay, so if... Okay, so if... Okay, what is the result? Okay, so we can do it like this. If result is different than, okay, I to C status success. Print or transmit to AS5600. Okay, let's make a new line over here and return false. Otherwise, so this should be bool technically. So then return true. Okay, so right. So now we need to read. Okay, AS56. Well, we don't really need to do. We don't need to provide any address or anything because the device address is fixed. And we already chose which register we want when we are writing. So read is just a read, like this. I'm very curious if it's gonna work. Okay, I to C. Okay, so we just send data and now we need to read. So I think we have to do receive over here. Okay, I to C. I to C receive. Okay, so the address is AS5600. It makes me wonder if I can read it like that, if I can put the result over here or not. Okay. Alright, so it's gonna be a little bit different. So we are getting pointer, something like this. Yeah, good that we have an example. Okay, so receive. Address is fixed. Data, so it's gonna be this one. Size of, that's the length. Okay, and timeout gonna be like this. So it doesn't have to be, so this would be bool as well. Okay, if result, if we don't have a success in reading it, okay, like this, and we return false. Otherwise we return true, and the data will go through here. Okay, address, data, size. Okay, and timeout. All right, that should be good. Okay, so we have kind of a template. I'm not quite sure about the init stuff, if we need to initialize, so hopefully not. Okay, makes me wonder this one. Okay, process record user, but I think this one only happens when we have a key pressed. I'm quite sure there was something else that we could use. Like there were different functions. Let's take a look. There should be something more. API. Maybe over here. Okay. So we have some init stuff. Okay, matrix scanning code. Okay, this might be it. Okay. Yeah, I would rather use this one. So we have over here matrix scan user, and this function gets called at every matrix scan. Okay. Okay, on the other hand, this might be a little bit spamming. Okay, anyways, housekeeping. Okay, so instead of this, I'm gonna use this one. So it's gonna be void matrix scan user void, like this. Okay, we're gonna remove that because we already have this stuff like put in a function. Okay, we don't need. Let's call this one. Okay, so this is where we'll be reading our stuff. Okay, let's call it data. This one won't be needed. Okay, so we have it initialized technically. And now with every scan, we would like to. Okay, we would like to write this one. So let's do AS write. Then we have the okay, AS5600 status register. Okay, so we write this. Okay, maybe that's enough for now. Let's see if we can even write. Yeah, okay. I need this for programming. I'm gonna put it over here like this. I wish it was smaller. Okay, we're gonna need something to read the debug, and HID listen is kind of nice for that. I'm gonna drop it here. I hope you can see it. Okay, over here, if we go back, yeah. Okay, so I have no idea what I'm doing. Let's compile this thing. Okay. Can I have it somewhere up? Over here I wanted to auto flash. Okay, and it's gone. Okay, this should be okay. All right, so okay, let's see what happens. Must be plenty of errors. Yeah, exactly. Okay, because we are not using it. So for now, I'm gonna comment this out. Okay, one more try. Okay, what is wrong? Yeah, right. This is a void function. Such obvious errors. Okay. Okay, what is this right now? Implicit declaration. Oh. Okay. I think I need to change that. I forgot about this. Because like over here, if we look at it, yeah, I think we need to change the address. Okay. Okay, so we can't write it like that. Okay. What a silly mistake. Have I missed something over here? Oh, Mr. Chiclapa77, thanks for following the channel. You're right on time for messy C. I think I might be the worst C programmer ever. Okay, what is wrong over here? Okay, it complains that something is missing. Okay, AS write implicit declaration. Okay. It doesn't like this. My god. How many more errors do I have like this? Okay, and what is wrong this time? Something's much more interesting. Okay, now it doesn't like... Okay, I think I know what's wrong. I forgot to include I2C master. How about now? And maybe debug.h, because we are using print. So yeah, this should maybe help. Okay, how about now? Okay, a little less errors. Maybe not. Okay, so I think that wasn't a good idea. I think for the registers we need to go with an enum like this. So let's call it rec status, and that will be this. So I guess the mask and all this stuff can stay like that, but yeah, I just picked over here, and they have all the registers they have in an enum, so we'll do the same. Okay, rec status. So we want this one. Oh no, this one. Reg. Okay. Okay, so yeah, we're gonna be writing, okay, this is what we need to write, the address. So this one we need to change to this. Okay, any new errors? Yes, of course. But we are getting there. We need to do size of. Okay, what is it complaining about? In AS56, right? Passing argument 2. Okay, so this is our I2C transmit, right? Makes pointer from integer without a cast. This sounds serious. It doesn't have to be const. Okay, let's do one more check. Okay, it's expecting address. Okay, so does it mean that we have to do something like this? Okay, so that is way better already. Something is off in keymap. Okay. Why do I have an impression that after we flash it, this MCU will just blow? Okay, no errors. Kind of scared to plug it in. Well, okay, who cares? Okay, one more thing. So maybe before we even start, would be nice if we could just, okay, pre-init, post-init. Okay, maybe over here, let's do post-init done. So at least we know that we managed to hit this one. Alrighty. Let's compile it. Okay, so that's our file. We have auto flash. Okay, ladies and gentlemen, let's see. Is it even gonna flash? Okay, it's flashing. And okay, flash complete. Okay, listening, and nothing is happening. There is no output. If I remember correctly, we have a button somewhere, so maybe we will be able to force it. Okay, let's do it like this, just to see if this thing even works. All right. This is gonna end up bad, I'm afraid. Okay, this one is not stripped. Where are wires when you need them? Okay, this one looks promising. Okay, so we have VCC over here. Okay, that's not what I was hoping for. Okay. No, so that's not it. Okay, just pressed K. And nothing is happening. Okay, so maybe for now, let's keep all this stuff. Okay, debug matrix. Okay, that was okay. Okay, let's keep reading. Because my code is so great that I'm not quite sure if this keyboard even works, like the basic functionality. Okay. Okay, let's flash it. Okay. Sorry about that, forgot to change. Okay, one more try. Oh, come on. Really? Yeah, because it's direct connect. Okay. Anyways, so this thing is fine. Well, okay. So now when I look at it, maybe it wasn't that bad. Maybe it was really working. Because it didn't print anything because maybe there was no error. Maybe it did print whatever you wanted to. I mean, maybe we did read that. Okay, so let's see. Okay, so now let's assume that our write and read are correct. Everything works. It didn't print any error. Either there was no error, or maybe it was going so bad that it couldn't even print anything. Now we're gonna try to read something. So we're gonna write this address of this register. So then AS5600 should give us back the value of this. And now we can do something like this. If we do data and if we do bitwise and what was the name of the mask? Okay, magnet mask something. Oh no, come on. Oh, okay, it's an error. Magnet. Okay, so if we have this value, so we should be able to tell, okay, so we can do magnet is in. Okay, so if we do else, then it will be spamming all the time. Okay, I'm kind of curious. Let's do something like this. No magnet. Okay, I think I ate one more. Okay. All right, let's see what happens now. Okay. Let's see if we can compile this thing. Right, of course we can't. Okay, so I assume it wants address, right? How about now? Okay. Let's flash it and see what happens. All right. Okay, magnet is in. Okay, if I remove it. Okay, I hope you can see it. Okay. Oh shit, it works. No way. Now it says no magnet. Magnet, no magnet. Magnet, no magnet. Oh shit, that is fun. Okay, awesome. I have to admit I wasn't expecting that's gonna work. Okay, so we are like almost done. I mean done. At least we are reading something out of it, so that is great. What should we do over here? Okay, we can do something like this. Let's say we would like to have a constant magnet detection, right? So we don't want it to spam all the time that the magnet is in or not. Maybe we can do something like this. So if we do static unsigned, okay. Okay, so now it's like this. Okay, maybe. Okay. Probably that's not the best way to do it, but who cares? Okay. Okay, so. Okay. So what will happen? If we detect magnet, we set this to 1. We print. Okay, we don't want it to print more than once. And over here we set it to 0 when we remove it. So okay, that would be because let's say we wanted to have just one output. Okay, let's not dwell on it. That is not important right now. What I want to read the data. I mean, the stuff that we are printing is not important at all. Okay, we know that it's like in or out. That is fine. What we need to do, we need to get to the. Okay, let's do it like this. What was the address? That one will be more tricky because we have to read it twice. Or maybe we can read, okay. Because the address for the rotation, for the angle is, I think it's 12-bit or something like that. Oh, where is it? Ah, yeah, over here. So the address is OE. It starts like this. Okay. So it's something like this, right? And so in this register we have only how many bits? 1, 2, 3, 4. Yeah, so we have 4 bits over here, and then the rest is over here. So I think this will be high and this will be low, if I get it correctly. Okay, so we have magnet stuff. So this will be 16-bit. Let's do it like this. 0. Okay, so over here so we want to read the angle register, right? So we have to use this, send this to. Okay, so we can either. Okay, let's try with 2 reads. So let's read it like this. Yeah, we can read data because 1 read is just 8-bit. And then we can take our angle, make it equal data, and let's shift it by 8. Should be like this, right? So it's gonna be angle equals angle shifted by 8. And now we can do one more read. And I think now we can do something like this. So it's gonna be bitwise OR and with the data, right? So we have 8 bits. Then we shifted to the left because we have the angle is 16 bits. So we shifted to the left. So that will be the upper register kind of. And then we gonna just OR whatever we read from this one. Okay, so now let's do print. Shit, what was the... I think it was print tech 16? No. Oh boy, I need to find it. I think maybe... Okay, print tech. Okay, so this is for the hex. Okay, so if we... Looks like we can do print decimal, right? And it doesn't really... Okay, the difference is only signed, unsigned. So this one will be not signed, so... Okay, so... Like this. And... print angle. Okay, I'm gonna skip this because they will be spamming. Okay, now I would like to print new line, so at least we will have some kind of like we're gonna have like line after line. So the angle is okay, this one is just like from 0 to 4095 or something like this. Okay, let's try to compile this thing. Okay, errors, yes, of course. Yeah, right, forgot about this little fella. Okay. Let's see what happens when we flash this thing. Okay, it's done. Yeah, we have some reading. Take a look at this. 1936. So let's see what happens if I move it. Oh shit, it works. No way. Yeah, that is so cool. Okay. So we are reading this. Okay, let's keep the logic because like when we rotate past 4090 something, 95, and now it's gonna drop to 0. Yeah, so that is easy to do. I already did that in Arduino, so I can fix it maybe even like off stream. That is not important. But what I would like to see is how about we do some scrolling with it? Okay, how can we do scroll? Let's see. I think we can do it like this. I might be able to... Okay, first of all, we're gonna need some kind of a variable to see if the angle changed, right? So it has to be static like this. Let's call it previous angle, right? I'm not sure if I think about it correctly. Okay. Like this is new angle. Okay, so we can do it like this. If previous angle is different from current one, so we're just gonna print it. Otherwise we won't. Okay. Okay, so and here should be like this. Am I getting this correctly? Yeah, okay. I'm not quite sure, but should be okay. We're gonna find out soon. Compile. Alrighty, and let's flash it. Surprise, no errors, although not much change in the code. It makes you wonder what will happen. Okay. Okay, so yeah, so it's not spamming all the time. Only if I... Yeah. Or is it? Difficult to tell. Yeah, it looks like it keeps going. Well, yeah, I think it keeps printing. Okay. Let's do a quick code swap from Chordie. I think we have... Okay, scrolling over here. Okay, or maybe it was in my different keyboard. Maybe that was in DVD or try to see. Let's check. Yeah, I think it was over here. Oh, okay, so we can try to use this one. We're gonna do like a custom. Okay, it's gonna get messy most probably, but who cares? And there should be defined somewhere. Okay, because what I would like to do, I would like to see how does it feel like when like we try to rotate with it. I mean, not rotate, do a scroll. Well, I see that my implementation is kind of broken either way. It keeps spamming. Maybe because it's kind of changing, because as I said, it's kind of sensitive. Yeah. That might be not the best idea. Ah, okay, I think I know, because it was also doing this for Arduino, so I think we need to do some kind of a margin of change, because I think the sensor, it's like reading, so it's always like plus minus 1, 2, something like that. So I think we can fix it if we just add like a margin of 20 or something. So it has to be, the difference has to be bigger than the previous value plus like 20 or plus minus 20, something like this. Then it will be okay. Okay. I see. Okay, over here I have it. We're gonna have to change that. But there's one more thing, because we have to add, what do we need to add? Like a special mouse key, no extra key. Okay, command console boot magic. Okay, pointing device. Okay, that might be difficult. Yeah, how can we quickly, how can we do it without like all this mess? I think we can do like a tab code. Okay, I think we can do it maybe a little different. Okay, let's skip this. Okay, we don't want that. For our stuff, okay, we have mouse keys, so that is okay. So let's jump over here. Where is it? Key map? No. Okay, we are here. Okay, I think we have to change that. So if previous angle, okay, plus let's say 25. How to do it? Let's take a look how I did that in Arduino. Might be faster. Okay, because righty. So it's a little bit different because I wrote this function, so get distance, and this one will return depending which one is greater. Let's do it like this. So we need to get distance, right? So it's gonna be previous angle. Okay, so if previous angle is greater than new one, we can do it like this. So return previous angle minus new angle. Definitely you can do it better. If it's like this. Minus like this, and everything else just return 0, because that will be when they are equal, if I'm not mistaken. Yeah, and so over here we can do it like this. if get distance, and we have previous one and current one, and if it's greater than let's say 25, so then we print, otherwise we don't. Let's see if this works right now. Of course there's an error. Okay, wrong type. Oh, maybe that's why it didn't work, because the type is wrong. Beauty of C, you have to be very careful not to shoot yourself in the foot. How about now? Okay, still error. What is wrong? Conflicting types. Okay, what seems to be the problem? I think I know what's wrong. I think we need to have it over here. Oh my god, see. Okay, how about now? Yeah, okay, so I think it needed like a forward declaration, but we can also swap it because I was using, the error was that I was using this function, but it was defined like over here. So once I moved it here, so the definition has to be before the first use. So now it's fine. I mean, at least it will compile. I mean, it compiled. If it's gonna work, no idea. Okay, let's flash it and see what happens. It shouldn't be spamming those values right now. Okay, nothing. If I move it. Okay, yeah, so now it's fine. Okay, so I think we can do we can scroll without using the mouse, because we have over here, I have include in this file, okay, I have include mouse keys over here. So the mouse keys should give us codes for kind of like moving mouse left and right and all this stuff, but it should also give us codes for scrolling. Let's take a look. Mouse keys over here. Okay, and we have these aliases. Move cursor over here. Okay, wheel up, wheel down. Alrighty. Okay, I think I'm gonna just like copy paste whatever I had in Arduino. So this way we should be able to just like, we're gonna definitely use these codes, these two. I think we can do like tap code or something like that. There was this function somewhere. So technically we should be able to just send like wheel up, wheel down without like much effort. Alright, this is getting very nasty. Okay, so we have distance over here. Because, okay, right now we gonna... Let's take a look. We have get distance. more like this. This will be get direction. So we have previous and new angle. All right. Okay, so if this one is greater than the previous one, so we're gonna just return 1. If it's the opposite, so we're just gonna return, okay, -1, so it has to be like this. Well, technically we can return 2, right? Okay, either way. Okay, that's gonna be -1. And otherwise, return 0. Okay, direction, distance, and then we can just jump to movement. We're gonna need one more static int. Like this. Good that I had it prepared already. I mean, I have it prepared. Okay, previous movement. Like this. Okay, and what do we have over here? Get movement. So it's gonna be again previous and new angle, right? Direction. Distance. Like this. Okay. And we need that because sometimes we need to know that it flipped like from 4000 something to 0. So I found that like having the distance at 2000 should be good enough. Okay, so now if this distance previous movement equals 1. Okay, so this will give us like the correct value. So if we rotate left, it will be telling us that we rotated left. If you rotate right, it will be right. So 1 and -1. And also it should allow us to proceed. For example, if we exceed the value, so if we go from like 4095, we jump to 0, but the movement is still like to the right, for example, then we'll continue with the movement. So yeah, that should be okay. Where is it? Okay. Okay, so we just need to focus on movement, right? Okay, so if it equals 1, then I think 1 was for the right turn, right? So let's do it right turn. So I think it was okay, tap code and going back here. So let's say it's gonna be wheel up, right? So this one. I hope it will work. Okay, wheel up is here. Okay, do we need to do it? Because it's gonna return something already. One more look at Arduino code. Okay, there is no default value. Alrighty, so makes me wonder if I can do it like this. Maybe I should just get the value somewhere. Save it in a way. Okay, so let's do it like this. And this is all like very ugly, but just to get it working. Okay, so now if movement is this, or if it's this, okay, let's say, well, okay, that's not right. Oh, it doesn't matter. Left turn. So we're gonna tap code down. Okay, looks like we have those keys over here because there was code completion for that. Okay. How many errors now? Okay, this one is undeclared. always miss something. Get movement. Okay, top code. I think it was top code 16 or something like that. It wasn't just like this. Okay, let's see. Okay, so there is top code delay. Okay, top code 16, so there should be something. Okay. Oh, this one. Okay, top code. Okay, so there is. Okay, so it doesn't have to be 16. Or maybe we are missing something. This one. Okay, so we don't really have to use 16. We can just use top code. I think I was missing this one. This include QMK keyboard. Maybe it goes. Oh no, it goes here. So let's see. Okay, better now. There's only one error. With movement. I think it complained that there is no like default. I don't think it will ever reach this one. All right, let's see what happens now. Okay. So, does it scroll or not? It doesn't. That is too bad. Okay, I think I know what the problem is. We have to move it over here. I think I did the same mistake with Arduino. Yeah. when I was doing this off stream. Okay, now it should work. So as you can see, I haven't learned. I wrote the same stuff twice and still did the same mistake. Okay, flash complete. Okay, does it scroll now? Yes, it scrolls. Wow. Awesome. Take a look. Yeah, the issue is if you remove the magnet, it will go crazy. I mean, we can fix that because we have magnet detection, so we can check if the magnet is in or not, and then just simply not output anything. But okay, let's take a look. Oh, wow. Awesome. Cool. We managed to get it to work. Great. That is outstanding. Yeah, with a good bearing, that should be nice. Okay, so now I have a dilemma because I don't know which one should I use. Should I go with this one, with mechanical one? Should I go with this one or whatever? This one's very nice. I think we'll go with this one because we can program it, so we can check if the magnet is in or not. We have a good control over like how much it's moving. Although with MT we can do kind of the same thing because we can change the resolution, but for MT it would still kind of like, it will still move even though the resolution is high. It might still move after some time maybe or something like that. This one we have like full control. Perfect. Oh, the scroll is so good. So much better than mechanical one. You can't move it this fast because it will start losing steps if you move it too fast. And this one you can go completely crazy. And yeah, if you flip the mechanical one this fast like this, it's done. There will be no output, probably it will be still 0. And with this one, yeah, it's perfect. I think we'll go with this one. Okay, cool, great. That is outstanding progress today. So I think we can finish on this. I am very satisfied with how it turned out, even though the code is shit, but that's fine, who cares, as long as it works. We can fix it later, like everything else. So guys, I will meet you probably on Wednesday. I will take one day off just to like reconsider like what do we need to do with Chordie. I know, maybe I should do some kind of a like a poll or something on YouTube. Not quite sure if it will have any response. Either way, I need to figure out with which we will be going, how to approach like the final steps for Chordie. And on Wednesday we'll proceed. We'll finish everything hopefully. Then Thursday, yeah, maybe on Friday. Okay, I'm not gonna talk about Friday right now. So for now, tomorrow is off. We meet back on Wednesday. We're gonna finish Chordie. Most probably we'll go with this one at least as the first design, because yeah, we can still go with anything else. But I think this one is the best, the nicest to scroll. Yeah. Okay. Thank you very much for joining today, for watching. I see you all on Wednesday. And yeah, enjoy your afternoon, have plenty of rest, and come back on Wednesday. Thanks for watching, and bye-bye.